Hello and welcome to our first chemistry class on this online tutorial. The topic we'll be treating today is stoichiometry of reactions. Now I chose this topic because I've discovered that most students have challenge in this particular area of chemistry. So throughout this week, we will be dissecting and looking at this topic so that by the end of this week, everybody here will have gained mastery of solving stoichiometric question. Now, what is stoichiometry? Stoichiometry is the calculation of amount of reactants and products involved in chemical reaction. You agree with me that for every chemical reaction, we have the product, we have the reactant, we also have the product. So the whole process of calculating the amount of reactants and products involved in a chemical reaction, either you calculate the number of moles, or you calculate the mass, or you calculate the volume of the product form, or the volume of the reactants involved, all these processes are involved in stoichiometry. Now, before we go forward, there are some terms we need to familiarize ourselves with. First, we have mole, molar mass, then we also have the Avogadro's constant. The mole of a substance, the mole of an element is the amount of substance containing Avogadro's number of formula units. The mole of a particular element is the amount of substance of the element that contains Avogadro's number of formula units. Now, what is the Avogadro's number? Avogadro's number is given as 6.02 times 10 raised power 23 units. So that's the Avogadro's number. So now the formula connecting Avogadro's number and mole amount is this. Avogadro's constant equals to number, which is the Avogadro's number, over amount. This amount is the mole. So this is the formula connecting the Avogadro's constant, the Avogadro's number, and the amount of substance. For mole, the formula connecting mole, reacting mass, and molar mass is this. Mole is given as reacting mass divided by molar mass. Remember that molar mass is the total number of the proton and the neutron, found in the atom of an element. Now, for the reacting mass is the amount or the gram of that element or compound involved in a chemical reaction. For example, the reacting mass of sodium chloride could be 25 grams, but you know that the molar mass of sodium chloride is more than that. Or the reacting mass of chlorine in a chemical reaction can be 10 grams, but the molar mass of chlorine is 35.5. So now that we have familiarized ourselves with this basic term in stoichiometry, let's go forward to learn how we can solve stoichiometry question. Maybe you see them in your exam. How will you go about it? Now, we have some basic steps in solving questions relating to stoichiometry. Okay, we are here now. Steps involved in solving stoichiometry question. Now, number one thing you do, once you are given the question, from the question, deduce the chemical equation from the question given. deduce chemical equation. 2, balance that chemical equation, because if you don't balance it, you will not get the right answer. Balance the chemical equation. 3, convert the unit of a given substance to moles. Maybe you are giving the unit, you are giving a particular substance, you are giving the unit in mass, or you are giving it in volume. You should be able to convert it in terms of mole. Then 4, using the mole ratio, calculate the moles of substance involved in the reaction. Then lastly, once you are able to calculate the mole of the substance involved, then you convert that mole of the given substance back to the desired unit. The question could be calculate the mass of calcium chloride formed when 2 moles of sodium react with 50 grams of chlorine. So the desired unit there is what? Is mass. This mass, you have to calculate the mass of the sodium chloride formed. So first thing, you need to understand the question. You understand the question, and from there you're going to carry out this 5 steps. And when you follow this step judiciously, there's no way you can go wrong. Okay, we have a question here. Calculate the amount of calcium chloride that can be obtained from 25 grams of limestone in the presence of excess hydrogen chloride. Okay, remember what I said? Deduce the chemical equation from the question. That is if you are not given the chemical equation, so you have to deduce it first from the equation, from the question. Okay, now we have that. We have calcium chloride. We have calcium carbonate, that is limestone. They also have hydrogen chloride. And the question says, calculate the amount of calcium chloride that can be obtained from 25 grams of limestone in the presence of HCl. So this means that our reactants in this question are limestone, calcium carbonate plus HCl solid. Thank you. Okay, so I assume that everybody already know that one of the products is calcium chloride. So, but what are the other products? Okay, for those who have taken chemistry classes for long, you remember that whenever a carbonate reacts with an acid, carbon dioxide will always be produced. Plus, remember, when acid reacts with salt, water also will be produced. So the last product here is water. That's gas, liquid, solid. So now the next step, like I said, balance the chemical equation. Now in this chemical equation, if I balance the chemical equation, you'll be considering the atoms, the number of. To balance a chemical equation, we will consider the number of atoms of each element in the chemical reaction. This time I will not be considering the compound in general, but the individual element, the number of atoms of the individual elements involved in this chemical reaction. So we're going to start with hydrogen, the number 1 element on the periodic table. So the number of hydrogen atoms here on the reactant side is 1. But the number of hydrogen atom on the product side is 2. So to make them equal, we'll just introduce 2 in front of HCl. So making the number of atoms of hydrogen the same on both sides. Now we go to oxygen. The number of oxygen atom here is 3, but on the reactant side it is also 3, so it's balanced. Then for chlorine, the number of chlorine atom here is 2, because this 2 here affects both hydrogen and chlorine. It is 2 here, while on the product side it is also 2, so it is balanced. Then carbon, the number of carbon atom here is 1, not 3, because this 3 is only affecting oxygen. It's only when a number is placed in front of a compound, that number will affect all the elements there. So the number of carbon atom here is 1. Also here in carbon dioxide, also 1. Lastly, calcium. Calcium here is 1. Then in calcium chloride, it's also 1. So now that we have balanced this chemical equation, the next step is to convert the given unit to mole. So what are the given units here? The given unit here is 25 grams of limestone. 25 grams of limestone. So how can we convert 25 grams of limestone to mole? Remember the formula for obtaining the mole of an element. Mole is given as reactive mass over molar mass. So the reactive mass of limestone here is 25 grams of limestone. 25 grams of limestone. And the molar mass of limestone can be gotten by adding the masses of the individual elements. So calcium is 40 plus carbon 12, which is 52, plus oxygen is 3 here. So 16 times 3 is 48. So when you add that, you get 100 grams per mole of limestone. So after our division operation, we have 25 over 100 mole to give us 0.25 mole of calcium carbonate. Okay, we have already converted the given unit to mole. 25 grams of calcium carbonate contains 0.25 mole. Now the next step is to generate our mole ratio. From the given equation, from the equation we have, this is calcium carbonate, this is calcium chloride. We have 1 mole. This is 1 mole of calcium carbonate, because there's an invisible one here. Will give us 1 mole of calcium chloride. 1 mole of calcium carbonate gives 1 mole of calcium chloride. But now, what we now have in this reaction is 0.25 mole of calcium carbonate. Give us what? X. We don't know. Then we carry out cross multiplication. We have 0.25 times 1 will give us x times 1. So make x the subject of the formula. X equals to 0.25 times 1 over 1. After our calculation, we arrive at 0.25 mole of calcium carbonate. So therefore, 0.25 mole of calcium carbonate can be obtained from 25 grams of calcium carbonate. So that will be all for this class. In the next class, we're going to look at relationship between quantity, because there are some questions you will see relationship between mass and volume. For this particular question we just solved, is a relationship between mass and mole, but we have a relationship between